Welcome on day 4 at 12:45. The next talk here is about smartcard protocol sniffing, a technical talk with an all-around attack on real smart cards in Switzerland. Please welcome Marc-André Beck and Bernd Fix.
Hi all, you hear me? Perfect. So let's start with a little poll. Whom of you is coming from Switzerland? Okay, and whom of you owns this card? Good. Whom of you owns this card? Oh, no one, okay. And whom of you is working for the Post Finance? Is here for training day or... Oh, no one? That's bad.
Yeah, that's a real pity because I'm quite sure that this workshop would qualify as an advanced training, as an advanced job training. So what a pity that no one from the card issuer is present, or at least doesn't dare to say so. Okay, thanks.
So, we break into this card, and first we thought we're going to find some Swiss cheese or Swiss chocolate inside, but in fact, we found a Swiss clockwork.
Okay, probably some of you have attended my last speech on the last Congress about the Swiss postcard, which explained a lot of details, how these cards are working, and especially the security flaws we found. So we will start with a short introduction into the last year's talk, so just to give you a connection point to what was already said last year. So we are talking about, as we said, about this Swiss debit card. It's not a credit card, it's a debit card, something like the EC card. Next, please. Which is a very old card by design. The design of this card started back in 1979. The banking functionality of it was designed in 1983, that's 25 years ago nearly. Which qualifies it as a very old and not probably, but certainly outdated technology. It's using a 320-bit RSA authentication scheme. I demonstrated last year how to break this very easy RSA key. So it takes about 12 hours on a normal PC to break the RSA key. So this card was already compatible with the French banking card, which was called Carte Bleue. And there was a guy in France called Serge Humpich. He was able to re-engineer the complete card. It took 4 years to do so, but he was able to analyze all the stuff going on the card. And he was able to clone the card and use it in a real transaction. Which was a good idea from a hacker's point of view, which was a bad idea because he had to go to court. He was convicted. The French guys have a very special relationship to computer security, as most of you know. So all about this car was already known. And in 2002, we just analyzed the Swiss postcard and found out it's identical to these French banking card, Carte Bleue. It exactly responded to the same commands, it has the same memory layout, and it has the same weakness, the same 320-bit authentication scheme with a different key, of course, but with the same key length. So we were able to break this authentication scheme to get the issuing key of the card issuer, which is the most secret you can have if you issue such cards, because it would allow to create new valid cards by yourself. Okay, I presented that on the last Congress, and that initiated some academic response. I know about at least 2 diploma works that describes the security flaws of this card. There were some seminars about that, but it was very low impact and very small media coverage in Switzerland about that. Which has probably something to do how Swiss deal with security problems, I guess. just as a side note, when the Postfinance heard about this talk, they said it's all wrong, it doesn't work this way, the keys are not used on the authentication scheme, and a lot of excuses, but they never said how it really worked. So the journalist asked them, if it's true that what this guy is telling is not true, why don't you sue him? And the Postfinance official said, well, if we go to court, we have to make the security scheme we use public, and that's not what we're going to do. So we're not going to sue him because we don't want to talk about our security schemes. And security by obscurity is certainly not the right way to do things. And just to demonstrate that, we planned a continuation, so we were not just technically hacking the card, but also practically. So the game, or the goal of this session is to demonstrate how we cloned a working card and did transaction with them. Okay.
So let's start with a short explanation what is a smart card. Most of you have already programmed an Atmel processor or a PIC. Smart card, in fact, is not anything more than that. It's a microcontroller with some RAM inside, some bytes RAM and not kilobytes, with a second EEPROM where you have all the applications, and what you surely know, the pad. Everyone sees this pad and has no idea what's behind this pad. In fact, as it is our connections, because in this card you cannot put a frequency generator. You cannot put a clock, so it's all passive. So we have an external clock, we have ground, we have energy source, we have the input-output, which is important for you, and the reset to reset the processor. And a microcontroller with an internal EEPROM and RAM, and an external EEPROM. That's a smart card. So everyone here can program his own smart cards at home with a speed of 5 megahertz working. Yeah. It's comparable to an old 8-bit PC, which the elder of you probably had at home, but with a little fewer passive elements. So if you would like to build this one, there are instructions on the internet, so you can make your own smart card also like this. Good, go to the second part of this presentation, logging the communication. This is an overview what possibilities we had to log the communication between the terminal and the smart card.
Okay. The last talk was about how the technical authentication scheme works on the postcard. It explained what memory areas there are, what's in these memory areas. We knew some basic commands, how to access the memory on the card, but what we actually didn't know was how real terminals talk to this card. So the first step in cloning a card is actually to know how terminals talk to it, not just to know the words it talks, but to get the sentences that are going back and forth. We knew already that this card uses the ISO 7816 standard for communicating with a terminal, which this standard defines all properties of smart cards, the physical dimension, the placement of the contacts, the sizes of the contacts, voltages, electrical signals, stuff like that. But it also defines a logical layer. It defines ways to communicate with the processor on the card by sending special formatted blocks of data back and forth. So that's something we knew already, but we had to find out how actually the terminal communicates with the card. We also knew that because it uses a standard, some properties of the communication can be a little bit fuzzy because the terminals have to handle a lot of different cards. So this leads to a tolerance. So we don't have to reproduce, for example, the timing up to the microsecond because the terminal will accept some variances there. And we knew that newer post-finance cards are actually EMV compatible, so we knew we had more information about the communication protocol in case of EMV cards, but we were talking about the older cards as well, so we had to log the communication between cards and terminals.
Even that the new card EMV compatible has a compatibility mode with the old standard.
Right.
They made it secure, but with the backward compatibility, they stayed insecure.
Which renders their statement useless that the authentication scheme is not used. If it's not used, why it's there anyway? Why is it there even on the newer cards? So it has to do something with their authentication.
So let's show some ideas we had to log the communication. Basically, the first one is hardware logging. Instead of putting in the smart card
into the terminal directly.
In the terminal, you put it like this and send the information to the PC. So it logs all the data that is transferred, even the timings, etc. That's rather precise, but also rather unfeasible in the terminal in the shop. I don't think they're going to accept this. So we had to find other ways, and a rather cool way would be, it ain't, but it would be, you have a thing like an RFID communication that just relays all the information coming from the terminal to my PC in the backpack, which is connected to my smart card. Yeah. Except that there's no implementation yet, but maybe someone would like to make this for next year. And so we decided software-based login. It was quite easy to program and use. Unfortunately, we had to go to the terminal, go back home, evaluate, go to the terminal, go back home, and evaluate. So we mostly used public terminals like
Public
phones, or things like this. Public phones don't complain if you put several times the smart card.
Okay, so if you do a smart or a software-based logging, you certainly have different ways to create a logger card. The two ways we did it was using a Java card, which is very easy to program, needs no special hardware to do that, which is actually limited in the protocols that can be logged. We have written a Java card logger, which is able to communicate with the terminal like an EMV postcard, which was able to log the communication going between card and terminal. But that is only possible for certain cards that support the so-called direct convention, which is a certain way of transferring data between card and terminal. And then, because there were some limitations and we wanted to go further, we also used real processor cards, so with no operating system on them, so we programmed all for ourselves. Just to give you a hint, we publish all the software we used and all the logging stuff written as a public in open source, which is available on a website we will show you afterwards. So you can get the Java card logger and the processor card logger for your own experiments. Okay, so we now had 3 ways to do logging. We can use hardware logging, which is HW here on the list. We have JC for Java card and PC for the processor card. And depending on what you need to log as the communication between the card and the terminal, you can make your decision what to use. If you need the timing, the exact timing of the communication, you have to use the hardware logging method. There's no other way to do that. If you want to support the block protocol for communication, you can do that with the hardware or the processor card. If you need direct convention cards, and this old post-finance card isn't a direct convention card, you need the processor card as well. Otherwise, you can use the Java card logging. And the only real difference between that is the ease of use. The hardware logging is actually difficult to use, not only because you have to put something into the terminal, which is probably not accepted if someone is looking after you. The easiest way to do that is, of course, the software logging. And to ease the use of, for example, the processor cards, we released this library to make the use of processor cards nearly as easy as the use of Java cards. The secrecy in both cases is high. Nobody will notice that you are inserting a card that is not intended to be used. And you need no special hardware if you use Java cards. You need special hardware to program the normal processor cards, but that's not so expensive. It's about, let's say, 50 euros, something like that. Okay.
So, go to the next step, re-engineering the protocol. I'm going to show you a quick example of the principles, how we did it. Then a hands-on example, and finally, how you could implement it yourself. Principles are, in fact, rather simple. You get a request from the terminal. You have a state list on your, and you have a lookup table on your smart card, where you look up this request in the good state. If you find the right answer, you associate it and send it back. If you don't find it, okay, you try with okay, maybe it works and we can go on. So if there's something new we hadn't logged till now, we start logging and the whole communication from now on to see how far we can get. And this, we are looping and looping and looping till the terminal tells us, shut up. Okay, then we go at home, put the information from the login card on our PC, send it to our smart card, get a good answer, save it on the logger in the lookup table, and start again. And then you walk out, go to the terminal, go back at home, and start again, and all the same the whole evening.
So you now understand why it's quite tedious. You have to, because you get one request, you don't know, you have to go back and get the response from the real smart card, which requires special hardware, so you can't do it. Normally you can't do it at the place you're testing it, which makes it really time consuming. So I spent nearly 4 days just to capture one complete communication protocol. But that's the only way to do it, and it's quite successful. You can nearly simulate the complete card by just this logging mechanism.
So, that's getting ugly now.
So this is something how it looks like as a complete picture. The first thing is, if the card is inserted into a terminal, it gets powered. And this power on actually forces the card to emit the so-called ATR, which is the answer to reset, which sends out a byte stream which identifies the card. So the terminal is able to make a difference between, or can find out what card is actually inserted, start the application for this specific card, and starts the communication protocol. So the ATR tells the terminal not only what card is inserted, but also some properties of the card, so it knows how the protocol looks like, if it's an indirect or a direct convention card. It can show things like programming voltages or extra guard times between characters. So if the card is a slow card, it can enhance the guard time between characters. Stuff like that is coded in the ATR. Everything is defined in the ISO 7816 standard I mentioned before. So anyone interested can look that up. And every application card issuer can add so-called historicals to the ATR, which is just only he knows what they actually mean. So there's no magic behind that in normally. Okay.
Maybe just Short hint, this is the answer to reset from the old postcard. The newer postcard, card, the EMV compatible, they have instead of the 3510 which has no exact meaning except that it shows it's an EMV card. So it's a convention and it doesn't work with the old standard.
So afterwards, the terminal is actually sending the first command to the card because it now knows what card is inserted. It knows it's a postcard, so it starts to send out the first request to the card. All the requests start with a byte, which is called the class code, which identifies the application on the card because the card can also have multiple applications on it, theoretically. BC is generally used for banking cards. Then there's the next one is the instruction byte telling what instruction the request is encoding. B0 is the ISO standard command for reading binary data. The next two bytes simply state the address from where you want to read the data. And the last one is the length of data requested. So you receive that request and the card, of course, answers with the sequence of bytes from that memory position onwards. Okay, followed of always by something that's called a status word, just to where the card can signal the terminal the status of the operation. If it's successful, it remits an OK, which is the 9000 status word, which is the normal word status for OK. And as you see, there are some commands in the sequence, just one back, which is just a sequence of read commands. So the first 4 requests coming to the card are just reading some data. And because we had the knowledge of the memory layout of the card, I explained that in the last talk, we know what memory or what data to return on these requests. Until then, these 4 commands are still stateless, which means the same request always generates the same response. There's no dependency on any other requests already sent to the card. But there are other commands as well, like this one, which is trying to access a protected area on the card, a pin-protected memory on the card. And if you just use this request or get this request, the card says, no way. I can't do that. This is the this memory area is pin-protected. You can't access this memory area. So you get an error code back. If you issue the commands for pin verification or cardholder verification, as it's called, and the cardholder verification is successful, the same command now suddenly returns the correct values. It actually reads the data from the protected memory and sends it back to the terminal. So we have something like a stateful lookup. The request we have to answer must know if a pin was successfully transferred to the terminal or not. So we need something like a stateful lookup, which complicates the scheme we have presented before. We did that by having a very simple data structure. Every request on the card knows the state it's in and the next state, the state transition. So if we have a pin command, we are switching the state. So the next time a request querying for protected memory data can check the state and deliver the correct response. Because it's a good thing of a terminal to try to access the data in a protected area before asking for the pin, just to make sure that the card knows what it's doing. And we have the same on the response side. The responses are linked to the requests, of course, with this index field, and we can either return data as a response to the request or simply a status word. So that's sufficient to simulate the complete communication between a card and the terminal. Oops. Okay. But that's not the end to it. If it would have been that easy, we didn't need to make a special clone of the card. We could just use a well-defined logger card with all the requests and all the responses possible, and that would be enough to simulate the card. But unfortunately, the same card gets treated differently in different terminals. So the terminals are not always sending the same request to do the same thing. Just as an example here, we have the Swisscom public phone, which we used mostly to do the stuff, and an SBB, which is the public transport, the public railway in Switzerland, the ticket machine. We see it accesses the same area of memory, but for example, with a different length. The ticket machine is simply not interested in all the data the Swisscom public phone is interested in. So we have the problem that different terminals talk to the card differently. And if we do that with a logger card, we would end up with an enormous list of requests and responses we have to handle. And that's not a good way to do a software clone.
So creating the software clone.
So we decided we had to do it a little bit differently. Now we know the communication between the card and the terminal. So we had all the information necessary to really create a working clone of the postcard. And we decided to do it in a way that we not used the request-response lookup scheme, but by really interpreting the instruction code sent to the card and to program an application logic that behaves like the real card. So what do you need to create this clone?
First, you need, as I explained at the beginning of this presentation, a special reader. In fact, special reader, it is cheaper than this one. And you can use it like this one, like a normal smart card reader. Yeah, ask probably for better Linux support or BSD support, Plan 9, Solaris, OS 2 Warp, whatever you like. They are open source drivers, we use them, but they aren't that good as I don't want to spell it here, the W word. So I
Let's say it's a very well supported in Windows, and I will explain later probably why. Okay?
Okay. Then you need a C compiler for an Atmel, or this place was for the Atmel, it's not for the PIC. And the library we provide on our website.
So that's the way to go if you're interested in doing your own experiments with logging and cloning cards. This will ease the pain of doing the communication side of the clone yourself. You can just use it and can concentrate on the application logic. But of course, you need something more. You need these cards, and you don't get them in every or in all the computer stores. So if you ask for a smart card, compatible microprocessors, you normally don't get them. So I had to look around till I found a shop who sells them. And I just will give a short summary of the dialogue I had with the shopkeeper when I came in and bought this card. I said, I'd like to have 20 fun cards, which is the name for these kind of cards. And he looked at me and he was quite a little bit baffled, and he said, well, are there any new keys out there? And then I was baffled. And then I had to realize where I am. I was not standing in a computer shop. I was standing in a satellite, in a company that sells satellite dishes, set-top boxes, stuff like that. And then I realized, he was talking about pay-per-view or set-top box smart cards. And I said, oh no, I don't need them for that. I need them for something completely different. And then he was baffled again. He said, really? There's some other use you can make of that? And I said, yes, I can. By the way, can I pay the stuff with my postcard? So you have a card, you can write your application logic, you can put the data on it. The only thing is, it actually doesn't look like the real card, which is probably not such a problem, because those of you who heard the smart card talk yesterday, they heard that the shopkeepers are trained not to look at what you're doing in the terminal, just for secrecy reasons. So probably you'll get away with just inserting a card that looks completely different, and they simply believe it's the real one. But we said, okay, if you have a CCTV filming the transaction, it's probably a good idea to have something that looks similar to the real postcard. So we started a Pimp My Smart Card workshop, and using just some simple paint. So the mag stripe on it's just painted, it's not real. And sure, if you give such a card to someone, he will notice the difference probably. But if you're just using it and someone looks from a little distance, he will not notice that it's not the real card. So you're quite safe using this clone cards. And that's it. That's all we did. And this is a working clone of the postcard. We successfully used it in the Swisscom terminals. So we just wanted to know the weather in Japan, and found the weather station in Japan, in Tokyo, which was quite expensive. And we didn't learn the weather because no one of us speaks Japanese, but we proved it working. And the thing is, although we cloned an existing card, the transaction never got booked to that account for whatever reason. The post finance, the issuer of the card, of course, didn't tell us. We don't know why. It worked. We did the transaction, but it never showed up somewhere. Maybe on another account. So if any one of you was the victim, I apologize. It was for a very good, it's the proof that it worked. And yeah, that's what we did.
So for further information about what we did, look at postcardsicherheit.ch. That's the website. There are all information about what Bernd did already last year and what we did this year. And if you go dig a little deeper, Parodie comme monétique. This is the page of Serge Umpich. It's not his page, but there are all the information you need historically how he hacked the carte bleue in France. And to start with the smart cards, you look at the simple operating system for smart card education.
Our library is actually based on the work done here with the sources stuff. So we just took parts of this GPL software, modified it for our use, and you can download it from the Postcard-Sicherheit web page, and can use it for your own stuff now.
Yeah, background academic. Surely there's books from Rankel. They're also available in English. And for the backgrounds of the carte bleue, these are mostly the French books. You will find information.
So if anyone interested, you get all this information also from the Postcard-Sicherheit webpage. So this is the place where to go. It's available in German and French. Unhappily, we are not able to provide the English version yet. Maybe some time. But you find all this information in quite a detail on that webpage. Also, what's on the mag stripe and stuff like that. So this is the place to go.
Questions? It's interesting. I held this presentation yesterday in a bar when I finished the presentation at the CCC. And I had approximately the same time. I thought I would be not that fast today.
But it was just a half an hour?
Just half an hour, yeah.
Wow, then we have a lot of time to
Answer
answer
questions.
questions. Wow. If there are questions.
You've managed to do this on a telephone system and something with the train. Are you also were you also able to do this with the ATMs?
It's always possible to do it on terminals that are not online connected in Switzerland it's the PayServe, which is the operator of the terminal network. So ATMs actually are online connected, so they have a different way of handling the postcard. It's not using the authentication. They are definitely not using the authentication scheme on the card. They are using the normal, like for the EC card, they do an online verification of the transaction. But every terminal that is at least capable of doing offline transactions is vulnerable to these clone cards. You know, that's the principle behind this postcard. The card can authenticate itself again for the terminal. So the terminal don't have to ask the bank if the card is valid or if it's the right one or if it's issued by the bank. The card can answer all the questions for the terminal itself. And the clone card does that like the normal card. So every terminal that is used for offline transactions as well is vulnerable. And those are all the terminals in places where you can do micropayment with a postcard. So you buy your chewing gum or your bottle of Coke with it. All these terminals in the kiosk area, they are all offline capable and they are vulnerable to this attack. Of course, this will change in the future. We know that. So more and more terminals will become online connected to the bank, and then this principle will certainly fade out. But it's still in use, and the best proof for that is that the newest postcards still support this old authentication scheme.
Yep. Could you give a...
Yeah, just a question. Did you have also a look on the German system, so they called Geldkarte, or?
No, we didn't. This is
Okay.
very specific about the postcard. Even other cards in Switzerland using chips are not covered by this principle. This is a very, very, very specific to the Postfinanz. And I have to say the following. I said that the original card in France was designed in 1983. Then the design principles were published, and in 1984, the first cryptographers talked about the insecurity of the authentication scheme. Even at that time, they said 320 bits is certainly not enough. Nonetheless, the French introduced this card 5 years later, and the Swiss even some years more. So, although it was known that the authentication scheme is vulnerable, they introduced that card. And this was our main interest. As I explained in the last talk, it's not a question of security. It's a question who has to pay for misuse of cards. And the problem is that you, as the card holder, are made responsible for any misuse of your card. The card issuer simply states, our system is secure, and if it's misused, you deliberately passed the PIN and the card to someone else, so it was your fault. And you simply can't prove that on court. How can you prove that you didn't do something? No way. So they do not refund your loss, and it's your problem, it's not their problem. And this is what really has to change. Banks have to accept that they are responsible for any losses done with these cards, and it's their task to make this system secure, and not the customer.
I'm a bit confused. You talked about 320-bit RSA encryption, but in the slides you showed, I didn't see any kind of encryption. I only saw the terminal transmit a pin to the card, and then the card then allows the terminal to read certain memory regions. I didn't see any crypto in these slides. So is it encrypted or isn't it? Or
the point is the encryption is not on the channel. It's not on the channel between card and terminal. That's all plaintext exchange. The encryption is hidden in the data transferred between the card and the terminal. So you see in the first block, the second last line, which starts with 2E033033, and the stuff following, which is anonymized. That's the crypted and plaintext part used for the authentication scheme. So if you want to know how that exactly works, go to the Postcard-Sicherheit webpage. It's explained in detail. It explains how you can read out your own card data and get the modulus of the RSA authentication scheme and how to break that. So encryption is not in the communication. It's hidden in the data transferred between card and terminal.
Hello. Thanks for coming and the interesting talk in the first place. Could you tell me something new about the political status? I recall you had contact with a very unsuccessful contact with PostFinance. Did you proceed on that, and did you consider making those transactions in front of the press and making them more public?
Yes. First of all, when the PostFinance in 2002 was so unresponsive to our findings, and we went to them to Bern and talked to them and said, you have a problem there, and they said, oh yeah, thank you very much for telling us. By the way, we know that before, but we didn't change it. And then we talked about that it's their obligation to refund misuse, and then they throw us out. And so we said, okay, we have to go to the next higher level. And the PostFinance, by the way, which is very interesting, it's not a bank. It's a company which is allowed to deal with money, which is something different. You know, it's not a bank. It's not under the control of the EBK, Eidgenössische Bankenkommission, which is responsible for the operations of the normal banks in Switzerland. Of course, like in Germany, the PostFinance is a spin-off of the state-owned PTT. And in Switzerland, the responsibility for the PostFinance is still within the government. So there is a high-ranking government official called Moritz Leuenberger, which at that time was even the president of Switzerland, who was responsible for the PostFinance, and we talked to him. Gave him all the information. He said, thank you, I will take care that this scheme will be revised, that the security will be enhanced, and that's it. 4 years later, when we checked what was actually done with the cards, we found out they did nothing. They didn't even change the compromised RSA key, not even that. And so we talked to him again, and he said, well, I advised my PostFinance officials to enhance security, and I'm sure they did it, and I don't know what's happening. So there was no way on that side to go any further. Then we talked to the press. There was one 2-page press newspaper article, which was released in May last year, which explained this stuff and showed the communication with Moritz Leuenberger. But the reaction to that press coverage was zero. There was no impact whatsoever. And we were in contact with the Kassensturz, which is a Swiss, a well-known TV show in Switzerland about consumer protection and stuff like that. They were not too much interested because we said from the beginning it didn't work with ATMs. And they were only interested in something really heavy. And so it faded away. Nobody in Switzerland really seems to be interested in the things going on, and that's the most amazing thing.
I have a question regarding I'm here.
Yeah.
I have a question regarding the transaction that you made with the cloned card. You said that the transaction wasn't booked on any of your accounts.
You know, yeah.
And I'm a bit confused because you said you have a cloned card in every respect. So is there something that you just did not get to know in the function of the card, or did you just guess some numbers?
You're on the right track. The first thing is the first clone of the card was the clone of my personal postcard. And when I received the card, you normally receive the card and then you get a special letter with a PIN to access the card. And I refused to accept that letter. So I got the card, but I didn't have a PIN for that card. So if you don't accept the PIN, you are, the card is rendered invalid. You still have it, of course, because they don't come and take it away from you, but it's not in the system anymore. So probably this is one of the reasons why nobody was built. So the other thing is that indeed there are 3 bytes within a range of about 2K, something like that. There are 3 bytes we don't understand, which is probably some kind of identifier even for the online transaction stuff. And probably that's the information they really rely on to assign a transaction to an account. It's 3 bytes, that means 17 million possibilities. We have about 2.5 million postcards, so the ratio is about 1 to 6 between the possible numbers and the numbers really used. And we made up some numbers, that's right. So there's always the possibility someone else was built for it. We didn't know. But it's also possible that when they really transacted when they really booked the transaction, they found a number they can't assign to any account. I don't know what happened at PostFinance at that time, if they just drop it or whatever, I don't know. So there are many possibilities, and I have to admit, there are really 3 bytes we don't understand. But maybe next year, I don't know.
Any more questions? Nobody wants to ask any questions? Then thank you. Oh, no, sorry. That's behind.
Do you know why no one exploits this in Switzerland?
Who
says that? I'm not sure if it's not exploited, because all the facts are now well known. They were well known even before we started. So to find out that the post-finance card, the postcard, is identical to carte bleue in France, it doesn't take a genius to find that out. And so probably some people do, and probably some people use it to cover their expenses. Nobody knows. The Swiss PostFinance don't talk about misuse and stuff like that. So we actually don't know if it's not exploited.
So if I got that right, it only works on offline terminals, so no ATMs, and also not terminals in the shops everywhere in Switzerland?
In the shops it works. Usually if you are in a shop in Switzerland, like the Coop or the Migros, they make bulk transfers. This means they don't validate every transaction. They save them all, and every 5 minutes they make a bulk transfer. So in 5 minutes you're away. They will realize it, but you're not anymore in the store.
But as I said before, more and more terminals now become connected. The old terminals, they had they were connected to the telephone line. And of course, then it makes no sense to initiate every transaction, to initiate a telephone call to the X25 network, to the operator. But nowadays, internet is ubiquitous, so more and more terminals get online connections, and this scheme will fade out over the next years, I'm sure.
Okay, here. Number 3.
Hello. Just to clarify, so you could make, with this information, you could make a reader that when someone inserts their card, you could read it out and have the information need to make a clone card in like a couple of seconds, or
If we have physical access, we can make a perfect clone. But with the key that we have correct, we can make a card for Donald Duck. That's
This
the
is
point.
the Donald Duck card.
okay, but you could make new cards
Yes.
as well as clone existing cards. So you,
Yes.
you can make and then defraud people.
Yeah.
And still So you can't. How expensive stuff can you buy with this card in the shops? Is it just for small micropayments, or is it for can I buy a TV with this card?
You can up to 3,000 Swiss francs, I think, per transaction.
Okay, so 2,000 euros about.
About that. Yeah.
Okay, so and journalists are still not interested in this. Weird.
Yeah, because you have to find out where it really works. I think the most, for example, MediaMarkt, where it would be very interesting to do that stuff. They have online terminals and that doesn't work. So you have to find out where it actually works. And our main point was to prove it, the statement of the Postfinance incorrect, as I say, this authentication scheme is not relevant whatsoever. So one transaction simply proves them wrong, and that's what we were mainly interested in.
But even with if they're online connected, if you clone a real card, then it would still work. So you could actually get a transaction
Only
debited to
if we
someone
have
else.
the real PIN.
If the PIN verification is done online, there's no way to do that.
Yeah, so if you create a fake terminal, like, I don't know, do you see the relay attack talk yesterday?
Yes, I did.
So if you do something like that, then no problem. Then you could, if you can get someone to insert their card into your reader and put in the PIN.
That attack would work out of the box, I'm sure.
Yeah, okay.
But it's a lot more complicated than just creating such a card. And if I said clone card, it doesn't mean you necessarily clone an existing card, but you clone the functionality of the card. And by having the issuer key, the private issuer key, you can create any new card that succeeds in the authentication scheme. That's the point behind it. And it's a question who has to pay, because you get some goods for it. Who's going, and the shopkeeper will get his money from the Postfinance, I'm quite sure. They can't say this transaction was faked, so you don't get the money. So I don't know what really happens at the Postfinance if such transactions show up. Probably they just ignore them, just to keep calm.
Any more questions? Raise your hand.
Okay, thank you very much.
Nobody. Thank you.